Welcome. So today, as I'm doing this, I think you all are either taking or preparing to take your first exam. I'm a couple weeks ahead of us. So we're going to talk about sequences. So we're starting chapter 8 here. Okay, so what is a sequence? Okay, a sequence, highlight because that's what we're talking about, is a set of numbers written in a specific order. I think I should specify it's an infinite or a numbered infinite set of numbers written in a definite order. Okay, one easy one is just going on forever. That is a sequence. Okay, so generally, well, we'll write it like an like this. If I'm being proper, I should put n equals 1 to infinity, but I actually don't really need to put that on there. So I could write it like that. Okay. And many, but not all, sequences we consider will be of the form a sub n equals f of n for some function f. Okay, so for example, one common sequence we'll use is a sub n equals 1 over n. That's a common sequence. Okay. Another way that we're going to use a lot, again, it's not the only way. Sequences can just become in all shapes and sizes and definitions, but another common way to define a sequence is recursively. Okay, so an example here, that means that it sort of depends on the previous ones. And this is something very common that we do in math. So an example here is a famous one, which is called the Fibonacci sequence. Okay, in Fibonacci sequence, you get A1 equals 1, A2 is equal to 1, but then if n is bigger than or equal to 2, I'm sorry, if n is bigger than 2, we'll say nope, it was bigger than or equal to, because we're going to do an plus 1 equals a sub n plus a sub n minus 1. Okay, so a sub 3, all this means is that we're adding the previous two terms together. Okay, so A3 is going to equal 2, A4 equals 3, A5 equals 5, A6, we're going to get this 5 and this 3 equals 8, A7 equals 13, adding the 5 and 18, and it goes on like this forever. Okay? So those are two common ways. let me finish off this slide with just two very common types of sequences that we're going to deal with. First type is what's called an arithmetic sequence. Okay, so an example is, say, 5, 8, 11, 14, 17. You can guess the next one's 20. And here we're just adding a constant multiple to our number. So we keep adding the same number. Very much like a linear function, or a line actually, okay? And it actually, we're gonna have the same sort of thing. Our an equals sum a0 plus d times n, where d is that constant thing we're adding together. So in our example, that's this example, d equals the 3 that we add every time. Okay, and then our a0 is what would happen if we just went back one more. Because this is a sub 1, not a sub 0. This 5 is a sub 1. Okay, so our sequence is a sub n equals 2 plus 3d in this case. Okay, all right. The other type of sequence that we're going to use a lot, or sorry, one other type of sequence, because we're going to use a lot more than just these two, but these are two good starting points, is a geometric sequence. Okay, let's do another, like an example. So here we're going to have a common multiple. We're going to keep multiplying by the same number. So 1, negative 1/3, 1/9, negative 1 over 27. Okay, so here we're basically dividing by negative 3 every time, right? Which is the same as multiplying by negative 1/3. Okay, so here these are of the form we're multiplying by a common factor. Okay, our form, we get a sub n equals a0 r to the n. Okay, our a0 is, again, this time it's going to be, well, let's do r first. R equals an plus 1 divided by an. So in our example, let me put r up here. In our example, r is negative 1/3. Okay, our a0 is going to be a1 divided by r. So in our example, we're taking 1 dividing by -3, by -1/3, is going to become multiplying the -3. Okay, so a sub n here equals -3 times -1/3 to the n. Okay, just check. If we plug in n equals 1, we're going to get -3 times -1/3 becomes +1. Okay? All right, I'll catch you all in the next video.